Hello YouTube. What I've got here is a setup to do what KitchenAid service manual for the old model K45 pre-solid state mixer, in fact newer ones have it too, is a test to see how much power the unit draws from the line under no load when there's no beater, nothing being mixed. The specification is that at low speed 105 watts to high speed 135 watts is acceptable. Anything more than that, I start getting the range of 175 low to 400 high, there's a problem. The mixer is rated at 250 watts, so even this condition, even in the best case, only about half of the rated power goes towards mixing stuff. The rest of it's associated with overcoming the electrical resistance and the friction involved, so the heat generation from electrical resistance and the friction from the gearing and bearings. So to do the test, I've run the mixer for a few minutes at high speed to get it warmed up so the grease is all warm. And I just happened to have acquired recently this nice Simpson brand model 390-2 voltmeter, ammeter, and wattmeter. Sort of unusual to have watts. It's a very rare thing in a meter to do that. Even modern handhelds that are expensive digital meters don't directly have watts. So for volts, we use the top scale for volts. There's two scales that have divisions on them, right? Those actual scales, ignoring numbers. The top set of numbers is volts when you just plug the thing in. You plug the watt meter in here and then plug your unit under test into it. Connect the wires in the expected ranges of current and voltage, and so you get a voltage reading just sitting here. It just measures voltage because it doesn't take, meter doesn't have any batteries. It's fully powered by the circuit, by the wall plug. So there's down here, it says volts normal, so without pushing either of these buttons, it just gives a voltage reading, which is the top numbers on the top scale. For watts, we use the bottom scale depending on what range you've selected. I've selected the 300 watt range. So the bottom scale of the divisions having the values at the very lowest set of numbers there at the very bottom numbers. So right now it's going to be 0 watts because there's no mixer running, and 0 amperes. So speed 1, we should have 105 or less. So the voltage is still it hasn't changed because it's just measuring the voltage, which doesn't change with the mixer. It's household voltage. Going to watts. Okay, it's short of it, so that first large division on the bottom scale is 50, 60, 70, about 80 watts. Yeah, just about 80. If it was to that first division with the numbers below it, it'd be 100 watts. So that checks good. Now going to high speed, amperes, it should be about that's 0.7 amps. The amperes is on the back to the top scale, but read the bottom numbers where it says 100, 150, 200, drop 2 zeros. So the amp scale is not linear. Notice that at the beginning of the scale, you have 0, then a first large black division, that's half an amp. Then the small divisions up to the first division with numbers is 10th amp divisions. And then after that, it's 10th of amp divisions, but they're larger. So it's not really well calibrated for reading low current, but there's current. But it does, it's really 60, 70, 0.06, 0.7 amperes. That's about what it gives. So volts times amps. In this case, the power factor appears to be unity because the wattage is the result of volts times amps. It doesn't always happen on AC, of course. Going to max speed. Again, voltage stays the same. Wattage should be no more than 135. And it is 100, almost between 110 and 120. So it's actually really good. So it seems to be really good shape, well below the specification. That first black division passed, the number says 150 watts, and then of course 200 is the division with numbers under it. So just to check that again. Number 1 speed stir, watts, between 70 to 80, bouncing around. Max speed, about 110. Actually very good. Watch, there's a phenomenon that will take place. What I'm going to do, I'm going to start the mixer at speed, run it at speed 10 with the watts button down. If I can do this with both my hands. And then 0 now, of course. And then turn the motor immediately down all the way to number 1 speed. Now what's going to happen is, the way this governor works, the motor will have a very small amount of power going through it, and the power reading at first will just be the resistor, the resistor being heated up, being in series with the motor during this deceleration. And as the motor slows down, the watts will get less because they'll actually get more, I'm sorry, because of the counter voltage decreasing. And then it'll finally, once the motor is in the circuit, again, it starts about the contacts start bouncing to keep the motor running at the low speed. You get about 10 watts difference. So there seems to be only about on average, a 10 watts at the low speed to the motor, and about 70 watts, 60, 70 watts being used in the resistor. So it's as resistance used for electrical control, it's wasteful of energy, but it's cheap and it's effective. So first to speed 10. There's that, like we saw, and then going to switching down to number 1 speed real fast and hitting the watts button again. See, then you'll bounce it slightly back up from that base deceleration. That's basically what I wanted to show, is that that when the motor's coasting down, the resistors in the circuit, and it's being heated, watts all are being dedicated to the resistor, and the motor finally takes over. Once it starts being governed, it takes over the 10 maybe 20 watt jump, but probably around 10 watts. So anyway, that's how I did this thing here. The way the way the book says to do it, from KitchenAid. This unit checks out wonderfully. It's really good condition inside. Commutator brushes, speed plate, all the goodies in it are original, and it works just fine. So it's a keeper. I wanted a non-solid state unit, and I got one. I got a good one. And I did the cleaning and the re-lubrication, all the adjustments myself according to the service manual. Anyway, I hope this is of interest to somebody on YouTube. Thanks a lot.